Yeah. All right, so like I said, today we're starting volume. First thing I want to go over is the units for volume. So if you have like just normal length, let's say this is 1 foot, we've already went over area is measured in square units, so obviously not drawn to scale. But this is a square foot. When we get to volume, it's three-dimensional, so the actual units that you use to measure it are cubic. So cubic feet, cubic yards, cubic inches, which would just look like a cube. So a cubic foot would be a foot in all three dimensions. So this would be a foot by foot by 1 foot tall, and this is 1 cubic foot. So main thing there to keep in mind for volume, your units will always be cubed. Okay, makes sense? It's three-dimensional. Even when we're doing surface area and talking about a three-dimensional figure, area itself is just square units. So does that kind of make sense? Any questions there before we move on? Okay. All right, so if you will go ahead and take a look at your notes. I think for the purpose of notes, I'm just going to start over the section numbers. So let's just call this 10.1. And this is going to be volume of prisms. Okay, so just focused on prisms today. I may see if it's not showing up very good, so I'm going to try turning off the lights.
You can definitely keep them off. This is new. I like this one.
Okay. Before I go over the formula for rectangular prisms, I actually want you guys to look down a little bit. In general, the formula for the volume of a prism, I'll just write it up here somewhere. The volume of any prism is the area of the base times the height. And I want to go over that real quick because we've already talked a little bit about the base of a prism is like the two parallel sides. Like let's look at a different shape here for a second. I'm going to look at a cylinder. Okay. Remember the base are the two sides that are congruent. Like on the cylinder, it would be the circles, right? And the height is the distance between those. So on this, your base would actually be here, and the height is like that because it's like laid on its side. Does that make sense? Now, I just use that for an example real quick. Because the same thing is true for a rectangular prism. In fact, let me just draw one for a second. If I have a rectangular prism, and let's say this is 4 feet by 4 feet. Sure. And 8 feet tall. I'm trying to find how many cubic feet are inside that. So does it make sense that I would do the area of the base, which would be how many square feet would be in that base?
Isn't it 4 times 4?
Yeah, 4 times 4. There'd be 16 square feet there. And then if I multiply that by the height, because it's 8 feet tall, if there's 16, that would be like 16 in one layer, right? If I kind of imagine that like full of cubes, there'd be 16 in that one layer. And then I would multiply that by 8 because there would actually be like 8 layers of cubes stacked on top of each other. So it's always going to be the area of the base times the height. But with a rectangular prism, that just ends up being length times width times height. Does that make sense? And it doesn't really matter the order that I multiply them in. With other shapes, it does matter because the area of the base is a little bit more complex, right? If that's a circle or a triangle. But with a rectangular prism, it's really easy. It's just length times width times height. Okay. So Rectangular prisms, super easy. I don't need a lot of work on those. Let me go back to the front here. Yeah. So for this one, again, I don't really care what order you multiply them in on a rectangular prism. But it would be 9 times 17. That would technically be the area of the base times the height.
I have no idea.
3,672.
That's what I
And what would my units be there?
got. Centimeters squared.
Centimeters cubed.
Cubed, huh?
Mm-hmm. Volume is always going to be cubed.
Great.
Okay. All right. Any questions there? Again, I think rectangular prisms are super easy. Okay. Now, then let's go on to number 4, I think is where it changes.
Yep. Looks pretty silly.
Okay. So on these, you can't just do length times width times height. It's not a rectangular prism. This formula applies to all prisms. That is volume equals that area of the base times the height. That doesn't matter whether it's a triangular prism, trapezoidal prism, a cylinder. The only thing that is going to change, let me move this over. The only thing that is going to change is how I get that area, right? That area of the base. If it's a triangle, I'm going to have to use the formula for a triangle. If it's a trapezoid, I have to use the formula for a trapezoid. If it's a cylinder, the base would be a circle, and I'd have to do the area of a circle. Okay. So on this one, the base is going to be this triangle. So how do I get the area of the base?
1/2 base times height.
Yep, and what I'll typically do is just do that capital B for base equals 1/2 the base of the triangle, which would be what?
12, right?
Yep, 12. Remember the base and the height, they're always perpendicular. Times,
7.3.
yep, the height, 7.3. Okay. And then I'll figure out what that is. 43 point what?
8.
Okay. And then I'm going to take that answer times what?
2.
Nope, 10 is this side of the triangle here.
5.
5, yep, the height is that distance between the bases.
219.
219 cubic feet. Okay. All right. Why don't you guys try number 5 on your own? Okay.
58.2.
Just a second, guys. So, yeah, on this one, it's laid on its side, but the base is still the two things that are congruent, right? The base is not that rectangle. This is a triangular prism, so the base would be this triangle in the front. And you can actually do this all at once if you want to. It'd be the area of the base, that triangle, so that's 1/2 times 11 times 5.4. That would give me the area of that triangle. And then the height is the distance between the bases. So this is like, imagine it's laid on its side. The height is actually the 16 here.
Are you serious? I put my height as 6
No.
because it just confused me.
Does that make sense now? Like, imagine it as a triangular prism, but it's laid over. Okay. Prisms, the bases, there's always two bases that are congruent.
How do you know that it's laid over? You know what I mean?
Well, so it can't be a prism this way, because remember, a prism is like the same all the way through. It has two congruent bases. So if I look at it like top to bottom this way, it's not a prism. I can't do anything there. So just like on the cylinder that we looked at,
Oh wait, I think I know why. Okay, I think I know.
just like on a cylinder, the circles are the bases, and this would be the height. Does that make sense?
Mhm.
Same concept here.
Okay.
And then so I do the area of the triangle and then times the height, which is 16. And you guys can actually do all that at once if you want. I just broke it down for you on that first one to kind of show you it's the area of the base times the height. This is the area of the base. So you guys can multiply that all together at once if
So
you
what
want.
the big answer? Is it 2851.2?
No. What? Was it 7?
475.2.
475.2 millimeters cubed.
Yeah, now I got 475.
Asking for a lot.
All right, we'll try number 6 then. So what, just real quick, what's the base gonna be on number 6?
Trapezoids.
Yeah, it's that trapezoid. And what would the height be? So if the trapezoid is the base,
17.9.
no, the height is gonna be the distance between the bases. Does that make sense at all?
Yeah.
Okay. Again, this is like laid on its, if the trapezoid is the base,
See, I just don't I don't understand how to tell that it's laid on its side, you know what I mean?
well, look for the two shapes that are congruent
Yeah.
and imagine that as like the top and the bottom. So you see the trapezoids?
Yeah.
Those have to be the bases. Those are the things that are congruent. And so then the height is just the distance between them. Okay.
Can you come check and see if I did this right?
Yep. Okay. So, got 1/2, 14 plus 16 for base 1 and 2. The height of the trapezoid is the 17.9. And then I'm going to take that times the height of the prism, which is the 25. You said that was 11,000 what?
11,187.5.
187.5 cubic meters.
Mr. Rod, how'd you get 16?
6.
36.
Oh, that should be 36, sorry. I was just going off of memory, I didn't look at it. All right, any other questions there? All right, let's flip over to the back. Okay. So on this one, triangular prism, what are the bases? The triangles, right? So I'm gonna have to do the area of the triangle. Just remember, sometimes it doesn't give you, yeah, this is 90 just like the back. I know this is 32.5, but I don't have that piece there. So I'm gonna have to do Pythagorean theorem because I need 1/2 base times height for the triangle. So that would be 28 squared plus x squared equals 32.5 squared. 28 squared, 576. 784. Okay. Subtract the 784 over. 2 what?
272.25.
Okay. And then square root.
16.5.
Everybody good with just solving for that missing side? All right, so now volume, I need the area of the base, so that triangle, so the triangle is 1/2 times base times height, so that'd be the 16.5 times 28. And then what would be the whole height of the prism? 31. So the first thing I would do is always figure out what the bases are. So that's the two triangles. And then the height is always the distance between those two things.
All right.
Okay.
All right.
All right. Let's go ahead and let's go through number 8. So what are the bases here? Yeah, the trapezoids. Okay. So the area of the trapezoid is 1/2. What would the base 1 and base 2 be?
36.
39.4.
Yeah, I can't see it.
25.
And 25, good. And then what's the height of that trapezoid?
35? No.
No, it's 30. Yeah, it's 35.
Is it not 35?
No, the height would be this distance here. So notice that it's a
Oh.
right angle.
Wouldn't it?
Does it give me that distance?
So that's
Pythagorean
confusing.
Yeah, this is, again, they kind of get harder as they go. So what I'm going to have to do on this one, I am going to have to do Pythagorean theorem, but where am I even going to set that up?
Not a clue.
So I'm trying to get the height of this trapezoid. So notice I can make a right triangle there, and I'm trying to get this length. I know the diagonal, the hypotenuse is 30.6. What would this distance here be?
14.4.
How the heck did you get with that?
I have to subtract base 1 and base 2.
Oh,
Oh my.
so would you do the yeah, what we just said.
Yep. So Pythagorean theorem, the hypotenuse is 30.6. So
One thing will take that sounds pretty fast. You should go. You're lucky to graduate in like 3 weeks.
yeah. So anybody got B yet?
27.2.
Okay. And again, just for the video, this 14.4 was the difference in the bases. When I made this right triangle, this was 39.4, and this side is 25. So the difference between them there is 14.4. So that 27.2, why did I need that?
There's no point. It's just 27.
Oh, just 27?
It's just 27.
The height of the trapezoid.
That was the height of the trapezoid. Okay. And then again, if I want to do the volume all at once, I'm just going to do what I have there, the area of the trapezoid, times what? Yep.
The height.
The height of the prism, which is between the bases. So which one would that be, Luke?
30. Is it 35?
Yep. It's the distance between the bases.
Would that make the video?
Times 35. And what do we get there?
We got 30,429.
Yep. 30,429. And just kind of a quick heads up, don't be alarmed if you get really big numbers with volume, because you're essentially cubing things. If you have just imagine you have a cube that's like 8 by 8 by 8, right? Just a perfect cube. you're multiplying 8 times 8 would get you 64, and then you take that times 8 again, and you're already in the 4 or 500s, right? So you're gonna get bigger numbers with volume than you would with area. Okay. All right. Last thing we've got is cylinders, and it's the same idea. Let me scroll down here. So it's the same idea. It is the area of the base. Move my camera slightly. So it's the area of the base times the height. But now, how do we get the area of a circle?
Pi r squared.
Pi r squared. So if you look over on the left, it just basically puts it all into one. Pi r squared for the area of a circle times the height, right? And you guys can do that all right away. So on this one, pi times the radius squared times the height, which is 15. And I would just do that all at once. Yep, 15,268. Was there any decimals?
0.14.
Wait, 14 inches cubed. Okay. So what is the first thing I'm going to have to do on number 10?
Get the radius.
Get the radius, right? Because it gives me diameter. So the radius is
5.5.
5.5. So it's pi r squared times the height of the cylinder, which would be what?
21.
Yep. Again, remember the height is always the distance between the bases. 1995. Point what?
69.
So number 11, it says a cylinder with a 2 centimeter diameter is drilled through a triangular prism shown on the left here. I'm not sure if I've got that in the... Okay. So this cylinder is drilled out, and it wants me to find the volume of the prism. So, like, what's left over is basically what it's asking. Okay. Yeah, I don't really care which one you find first, but I'm going to have to find the volume of the triangular prism and the volume of the cylinder, and then just subtract them. So let's do the triangular prism. So for the triangular prism, volume is going to be one thing that you can't, it's really hard to tell, but that is a 90-degree angle in the very back. So how would I get the area of the triangle? Yeah, 1/2 base times height, and those are going to be the two perpendicular sides there. So 5 times 5 times the height of the prism, which is 14. Let's get that answer. What's that?
175.
Okay, yep, so the volume of the triangular prism is 175. Now I want to find the cylinder, which is pi r squared times the height. What's the radius for the cylinder?
1.
Yeah, up here it tells me it's a 2 centimeter diameter. So the radius is just 1. And the height would still be the same as the triangular prism, right? 14.
It'd be 43.98. Would we just round that to 44 then?
43.9. Let's just leave it 98 for now. So now to get the what's left, just take the 175 minus 43.98. What was that again?
131.00.
And that would be cubic centimeters. Here's another, I know you guys don't like the metric system very much, but here's just another kind of nice thing about metric. You know how in standard, if I want to convert, like let's say I calculate the volume, let's say you've got like a tank that's like a rectangle. I could calculate the volume if it was like so many feet wide by so many feet long. I could calculate the cubic feet really easy, just length times width times height. But then if I wanted to convert that to gallons, it's like a weird conversion factor, right? I think there's like 3.8 gallons per cubic foot or something like that. Well, in metric, a cubic centimeter is a milliliter. So it's like the conversion from volume to like the length units is just like a straight conversion,
Huh.
which is kind of nice.
Heck yeah, dude.
So, all right. Okay, so it says Eric's got a pool shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 cubic feet per hour flow rate. How many hours will it take to fill the pool? Well, the first thing I want to point out is that this diagram, it shows like 4.5 feet tall for the pool, right? But he's only going to fill it to 4. Okay, so the first thing I need to do is figure out like what volume is that going to be for water. Okay, so volume for a cylinder is pi r squared. The radius would be
13.5.
and then the height would just be 4 because that's all that he's going to fill it to. So let's get what that is.
2290.2.
Okay, cubic feet. So that's how much water it's going to take to fill up this pool.
Wow.
And now his garden hose has a flow rate of 80 cubic feet per hour.
So you divide it by 80.
Yep, just divide that by 80.
28 hours. Or,
Yeah, 28.6.
28.6.
Yeah.
Now, in real life, this conversion would, or this problem would actually be harder because most stuff's not going to be rated in cubic feet. It's probably going to tell you like so many gallons per hour. So then you have to convert gallons to cubic feet, which.
Makes everything complicated.
So, but anyway, that's it for today.